Alright, today we're going to do a little recap or just kind of go over a couple of problems from the different sections that we've covered so far, section 1.1, 1.2, and 1.3. So everything about functions that we've talked about so far. Okay, so our first example, write the linear function that has the indicated function values. So if I know f of 2/3 equals negative 15 halves and f of negative 4 equals negative 11, I want you to pause the video and go ahead and write the linear function that has those indicated values. Okay, hopefully everybody got the correct answer, but we're going to go through that. So we want to make sure first we understand what is this even asking us to do, and sometimes that's the most difficult thing in mathematics. So it's telling us that it's linear, and it's telling us that it's a function. So it's saying write the equation of a line. And we're given two different pieces of information. This is representing a point, and this is representing a point. So can we write the equation of a line given 2 points? Hopefully. So the first thing we want to do is we want to find the slope. So I know the slope is going to be negative 11 minus negative 15 halves over negative 4 minus 2/3, and this equals negative 7 halves over negative 14/3, or 3/4. So I know I have a slope of 3/4. Once I have the slope, I can go ahead and I can write my answer. It doesn't have to be in function notation. I'm going to use point slope form because that's easiest with the information that I have given. This is going to come up a lot throughout the year. Make things as easy on yourself as possible. Unless it is specified, give the easiest answer for you to write. Sometimes it will say that it needs to simplify something into slope-intercept form. Sometimes slope-intercept form is more useful. But other times it's not. Sometimes point slope form is more useful. So do whatever is easier. In this case, that's going to be point slope form. So there are going to be actually two different correct ways in which I could write the answer to this problem. I could say y plus 15 halves equals 3/4 times x minus 2/3, or I could say y plus 11 equals 3/4 times x plus 4. So either this or this would be a correct representation of the linear function with the indicated function values. Okay, so next, find the coordinates on the graph of a function f if the given point is on the graph and the function is even and odd. So what that's saying is these points are on the graph. Now write points that you also know have to be on the graph if it is even and if it is odd. So take a minute, pause the video, and come up with those points. Okay, so hopefully you got the answers, but we're going to go through again how to do this. So if it's even, remember we know then that f of x equals f of negative x. What does that tell us? That tells us that for this point here, the y value should stay the same and the x value should just become opposite. So this point, I know, has to also be on this function if it is even. So the point 10, 21/3. I also know here negative 14, negative 5 has to be on that function. If it's odd, I know negative f of x equals f of negative x. So what does that tell me? Well, that tells me that for this point, I'm going to make both the x and y opposite values. So this is going to become 10, negative 21/3, and here this is going to become negative 14, 5. Okay, here I want you to evaluate this piecewise function at the indicated values. So again, pause the video, take a minute and do that. Okay, so hopefully we got f of negative 2 is 1, f of 0 is 5, and f of 1 is 1. Again, just real quickly, how do we get that if you did not get the correct answers? Well, if x is 1, then I'm looking at this piece of the function. So if I plug in 1 here, 2 minus 1 squared is 1, 2 minus 1 is 1. Okay, if x is negative 2, then I'm looking at this piece of the function. 2 times negative 2 is negative 4. Negative 4 plus 5 is positive 1. And if x is 0, I'm looking at this piece of the function again. 2 times 0 is 0. 0 plus 5 is 5. Alright, next example. Find the real zeros of the following function. So again, pause the video, take a minute, and find the real zeros of this function. F of x equals 6x cubed minus 13x squared minus 5x over 5x. Okay, so this is an example where we have to be a little bit careful finding the zeros. So we know to find the zeros, we set the function equal to 0. So if I say 0 equals 6x cubed minus 13x squared minus 5x over 5x. Now, if you remember the example that I did a few days ago, what we did next was multiply both sides by the least common denominator to get rid of that. And so we ended up here, we'll get 0 equals 6x cubed minus 13x squared minus 5x. I apologize, that's a sloppy squared. Now we can factor. I know I have at least a greatest common factor of x. So 0 equals x times 6x squared minus 13x minus 5. 6x squared minus 13x minus 5. This is also going to factor. So we end up with 0 equals x times, let's see, what is that going to be? 2x minus 5 and 3x plus 1. So if I set each factor equal to 0, I'm going to get x equals 0, 2x minus 5 equals 0, 3x plus 1 equals 0, and therefore I would get x equals 0, x equals 5 halves, and x equals negative 1/3. So now here's an example of where I did all of my algebra correctly, but one of those answers is wrong. Maybe you already pointed this out or recognized this right away, or maybe you went about the problem slightly differently, and I'll show you that in a minute, and you didn't get the false answer. But this is not an actual answer. Well, how do I know? I know because if I look back at the original function, I had a 5x in the denominator. You may not remember everything about asymptotes, but that tells me that I have a vertical asymptote at x equals 0. And I cannot have an asymptote and a 0 at the same location. So therefore, x equals 0 is going to be a vertical asymptote. It is not going to be a 0. Now, one thing I might have done differently in the beginning is I might have factored out that common factor of x from the start. So if I wrote this as f of x equals x times 6x squared minus 13x minus 5 over 5x, and I simplify the x's right away, now that's gone, and when I go ahead and continue solving for my zeros by setting the function equal to 0, then I'm not going to get that false x equals 0 as a 0. This is something we have to be careful about, though. You want to try to avoid eliminating variables when you're solving equations. Sometimes that will make you lose answers. So you have to be careful about this, and you really have to have an understanding of what is going on in the original function. And so that's why we want to understand that we have a vertical asymptote at x equals 0, which is telling us that the domain of this function, so the domain would be negative infinity to 0 and 0 to infinity. which tells me that x equaling 0 cannot be a 0 solution, root, or x-intercept of the function. Alright, next example. Find the relative extrema and increasing and decreasing intervals for the following function. So again, pause the video and go ahead and do that. Okay, so maybe you tried to factor this by grouping, realized it doesn't factor by grouping, and actually we're not trying to find the 0, so that doesn't help anyway. We need to use the calculator for this. So put this into the calculator, I put this into my y equals, and then I hit zoom standard, and I see my graph. Now from here, I want to change my window again slightly so that I can see the relative mins and maxes, and so I'm going to change the y min this time to, let's say, negative, I think 15 will probably cover it, but maybe not. So if I graph that again, okay, now I can see the minimums and the maximums. So I'll do second trace. Let's find the minimum first. So for a left bound, I'm going to use 1. For a right bound, I'm going to use 4. And then I hit enter, and then the guess doesn't matter. So I get 2, and then negative 13. Again, I don't like to use the word error, but it's basically an error in the calculator and how it's finding the minimum based on the pixels on the screen and the bounds that I chose. So I need to understand that that's actually 2. It doesn't mean that we always are, it's not rounding. That's not what I'm doing. It's the actual value is 2. So I have a relative minimum at 2, negative 13. And then next we'll find the relative max. So if I go back to the calculator and I do second trace and maximum, and for my left bound I'm going to do negative 1, and for my right bound I'm going to do positive 1, and then I do guess, the guess doesn't matter, and I get negative 1/3, and then I don't know what that is as a fraction, so I'm just going to write down the decimal approximation for now. So negative 1/3 and then negative 0.296. Okay, so then find the extrema and the increasing and decreasing intervals. Well, okay, so I want to find the increasing and decreasing intervals. I can look at the function, I can see it's increasing up to the maximum, then it's decreasing, and then increasing to infinity. It has a domain of all real numbers. So I know the increasing is negative infinity to negative 1/3, and then from 2 to infinity. And then I know it's decreasing from negative 1/3 to 2. Alright, so last one. The height y in feet of a baseball thrown by a child is given by the equation below, where x is the horizontal distance in feet from where the ball is thrown. Will the ball fly over the glove of another child 30 feet away trying to catch the ball 5 feet above the ground? So pause the video, take a minute, and solve that equation to answer the problem. Okay, so we need to understand what is this all telling us. We know that x is horizontal distance, y is vertical distance. So I can plug in the 30 for x to see what is the y value at 30 feet. What is the height? If it's 5, then they'll catch the ball. If it's not, then they won't. So y equals negative 1/10 times 30 squared plus 3 times 3 times 30 plus 6. And if I put that into my calculator, that equals 6. So to answer the question, will the ball fly over the glove of a child 30 feet away trying to catch the ball 5 feet above the ground? Yes. Ball will fly over the glove. And this was